Hi guys, we will now explain a little bit about our EV conversion kit. So we will start from the right side. We have AC motor, 3-phase, 15 kilowatt permanent and 30 kilowatt peak power. AC 3-phase, water resistant and homologated. It's the same as the inverter. So this is DC power coming in, converting it to AC power, and also the water resistance, so it can be integrated and installed in any car. On this side we have a small power distribution box. So this is a 12 volt system. This is a car battery, 12 volt, the same car battery charger. So this is DC-DC converter that converts high voltage to low voltage for charging the car battery, existing car battery. This is the vacuum braking system, so vacuum pump, vacuum tank and vacuum sensor for activating vacuum pump based on the vacuum inside of the tank. This is a DC water heater, so this is used for heating your car. So it connects in the same way as it was the usual car heating system before in your car. So this is the inlet, this is the outlet, so cold water comes in, hot water comes out. This is the water pump that makes this flow, and this is a controller that controls temperature inside of the heater. This is 2.4 kilowatt, so it's very powerful, and it gets very warm in under 30 seconds. This is the AC compressor. This is a 900 watts. There is also a 2400 watts bigger compressor. All depends on what you exactly want. This is a charger. You can connect multiple chargers to get more power. This is a 2 kilowatt charger which connects using PP and CP connectors to the Type 2 socket, so you can charge your car in any charging station using Type 2 socket. So this is a high voltage power distribution box that is connected to the power supply. So here is the power supply, currently at 98 volts. So positive, negative wires coming, negative coming to the shunt, and powering the inverter, and positive coming to the fuse over the relay, charger, heating, AC and DC-DC. DC is charger for the car battery. So if we activate the charger here, we would be activating this charger, so we can charge the car battery. This is the heating, so activating this would activate the heating heater there. AC is for AC compressor, and DC is for the DC-DC converter, which uses 96 or 98 volt in this case, and converts it to 13.6 or 7 volts to charge over this power distribution box to charge the existing car battery in your car. Now we will activate the system and see how it works. So using the key, we see now that the car battery is at 13.6 volts and that system is activated. This is only for so you can see that see the voltage of the system and that you know that is activated. For high voltage system we have this display which shows currently amps in usage. So this minus example shows that we are currently consuming power from the car battery. When you will be charging it, then will show the plus sign before, and it will show amps when charging, or also when using regen braking in the car, it would go in positive or in charging system. Each of these in the car battery, each of these lines represents 10% of the car battery. This is the voltage of the system, so it's 98 volts like we said. This is the remaining amp hours in the battery, and this is the percentage of the battery status. This is connected to the shunt, so it's connected to this shunt, and all current going in and out from the battery goes over the shunt, so you know exactly the percentage of your battery. Even the battery heating BMS is connected to this shunt, so everything goes over here, over the shunt. So B- is only for battery line direct, and P- is for all consumers and chargers that need to be connected to the car battery. And positive side has the fuses, so you can secure the wires you have in your car or the system. Now we will be activating the DC converter, so you can see so we have the voltage of 13.4 volts and amps consuming from the main power supply or the car battery. We will now activate the switch, and you can see the slight increase in the amps, and also voltage goes to 13.7 volts. If I would disconnect the voltage, the fuse, the voltage would drop slightly because the car battery is currently full. So if we start it again, the voltage would go up to 13.7 or 6 volts, depends on the car battery. This is example of the heater, so we can start it here. So using the switch, some regular switch, you would be activating the water pump, and the flow of the water would start, and also the electronic that controls the heater would be activating and powering on and off the heater, depends on the temperature of the inside of the heater or the water. For the chargers, you can connect multiple of the chargers. Since it's 2 kilowatt for the AC charging at home, you can connect, let's say for example, 3 of the chargers to get 6 kilowatts of charging. So it all depends on how you want to charge. You can also connect it in multiple ways. Let's say for example, you can connect one charger to one phase, other to other phase, and third one to the third phase. Or you can connect all of them to single phase. Depends on how you have your electricity at home, or even you can combine, like let's say for example, you want to charge at home at 2 kilowatts and at the charging station with 6 kilowatts, so you can connect one charger to each phase, and that will allow you to connect to charge at home at 2 kilowatts and at the charging station using all 3 phases and add the 6 kilowatts. You can connect even more chargers, but this depends on the space you have in your car. So this is our new power distribution box that has automatic switches, and it's easier to activate or deactivate something if you need to test something or replace something in your car. And also it's much easier to return the switch, because you don't need to return the fuse if it's burned. Also, these switches come in different. These fuses come in different sizes, from 10 to 80 amps, for the consuming part of the load, not for the motor. Motor is using the big switch, the big fuse, and also there is additional fuse inside here, and one more inside of the battery. So we have weakest fuse here, stronger fuse here, and more stronger fuse inside of the battery, car battery. So this is to keep your car secure, and also to prevent any issues or with the cables, or that something bad can go wrong. We are usually using LFP batteries, so they are more stable, more durable, and much more secure, because they are not flammable like lithium-ion batteries. For any additional questions, you can freely contact us and we will try to explain. You can also check out our other videos to see how we develop car batteries or additional batteries, or how this system works in some cars that we presented, or even other instruction videos. For those buying our EV kit, you get access to detailed explanation of each line and how it all connects, and also PDFs, schematics of each wire explained and how it needs to be connected, so you can easily install this kit in your car. This is a short video about this. We can also a little bit start the engine so you can see how it looks. So this is the accelerator pedal. We'll press it a little bit. So this was an example of how it works. On the motor and the control side, we also have active air ventilation. So this is for if you go in an uphill and for a longer time, this can cool the engine because it's air cooled, and it will prolong the life of the engine, since the airflow will reduce the temperature and make all components or wires inside the motor to stay cooler, and that will prolong the life of the motor. The same is for the inverter. Has a ventilation system to keep it cooler, and it connects to the same 12-volt power supply that goes from 12-volt power distribution box to this side where the wires are connected. Keep subscribed and keep following us to get more details about our new products and how all will look in cars, and some videos of the clients.